Welcome to Study Loop.
Okay, so before solving the problem, let's look at what's happening there in terms of physics. So first, the two capacitors are connected with a battery, and the total charge that we have in the capacitor is Q1 plus Q2. So that's the total charge that the capacitor has right now. Now, once they're disconnected and connected back again, but now the signs have changed, so that means it's connected in an opposite sense. So in this case, the charge will be so one thing that we should see here is, since the voltage is or the battery is closer to capacitor 1, so this will be charged more than this, so that means Q1 will be greater than Q2. So the total charge here will be Q1 minus Q2. And as we mentioned, Q1 is greater than Q2 by conservation of charge, this should be the case. Now, after they're hooked up for a long time, this reaches an equilibrium, and then we have a charge of Q1 plus Q2. Right. Now, since this connection and that connection, there's not much change because there's no external power source. That means we can actually say the charge over here should be redistributed to get this charge. So we can figure out one relation from this setup, which is Q1 minus Q2 is equal to Q1 plus small q1 plus small q2. So that's one relation. Now, the other constraint that we have here is the voltage. Since the capacitors have reached the equilibrium phase, that means the voltage will be same for both of them. So we know that charge equals capacitance times voltage. So from there, voltage should be charge over C. So in this case, it's going to be Q1 over the capacitance of this. So let's actually mark that here, C1, C2. So Q1 over C1 should be equal to Q2 over C2. So that's the second relation. So this is the first constraint, this is the second constraint. Okay. Um, so what we can do from there is, so we need to solve for Q1 and Q2. So we have two equations and two unknowns. So to proceed, what we do here is, first we use the charge equals capacitance times voltage relation, but for the first case, because we know the voltage that's been that's coming out of the battery, and then we know the capacitance, so which is this. And if we plug in the values, so given values are 2.2 microfarad, so that's the capacitance for the first capacitor, for this capacitor, and then the voltage is 24 volts. That gives us the charge as 52.4 microcoulomb. And similarly for the second charge, it's going to be C2 times V, and then it's going to be 1.2 microfarad times 24 volts, and that's going to be 28.8 microfarad. So yeah, that's one way to see, that's one way to mathematically prove that this charge is lesser than that. So since the capacitance of the second capacitor is lower than the first one, and they are getting the same input voltage, so that means the charge on the first capacitor should be greater than the charge on the second capacitor. So forget about this one being closer to the battery. That doesn't make sense, because if they're in parallel connection, they both should receive the same voltage. But we should actually look into this formula over here, where the only thing that's changing is the capacitance. And for the first capacitor, and we see that the first capacitor is bigger than the second capacitor. That's why the charge on the first capacitor is bigger than the second one, right? um, so from here we can actually use this equation to get a relation between q1 big q1s and small q's, big q's and small q's. So let's actually make this a little bit smaller. There we go. Now what we can do here is we write q1 minus q2, which is equal to q1 plus q2. Yeah, let's write that equation one more time. So if we do the subtraction, we get 24. There's one correction over here. It's going to be 52.8 actually. Yes. Right. So when you do the subtraction, we get 24 microcoulomb, which is equal to q1 plus q2. Right. So from there we can express q1 in terms of q2, or q2 in terms of q1. So that means q2 will be 24 microcoulomb minus q1. So then we can use this second relation, the relation between q1 and q2, and substitute q2 back here, and then we can solve for q1. So what we're trying to do here is, let's write the equation one more time. It's q1 plus c divided by c1 equals to little q2 divided by c2. Then q1 by c1 is equal to 24 microcoulomb minus q1. So 24 microcoulomb minus q1 divided by c2. Now we know all the values, and if we other but q1, so if we solve for q1, we get 24.0 microcoulomb over 1 plus c2 by c1. And if we plug in the numbers over here, we get 15.5 microcoulomb. And if that's 15.5, then if we plug it in here, we get q2. So q2 will be 24 minus 15.5, which is 8.5 microcoulomb. Thank you.